Okay, my name is Marc. As we said earlier, I'm a principal engineer at Flipdish. I'm going to give a really quick intro about what Flipdish is and what we do. So we make every software that a restaurant needs, typically a quick service restaurant, so takeaways, deliveries. We make apps for online ordering. We make websites, kiosks that are physically in the store. We do the point-of-sale software on the till. And we also have devices in the back, so screens in front of the chefs telling them what they need to cook. These are our kitchen display screens. We have printers, label printers, so the full stack right from the consumer ordering food in their app all the way through to the delivery driver delivering the food. So we launched in 2016. We've handled 50 million orders to date, and we do about 1 million orders per month. So when we're talking about back end and scale, these are the sort of numbers we're talking about. We're going to be focusing on the back end today, so I'll give a quick overview of what the back end does. Food orders come in, so they might come in from iOS, Android, from the web, but also orders come in from outside of our control. So a Just Eat order, an Uber Eats, Deliveroo orders, in-person orders, orders over the phone, they all come into the system. And then we send the orders out to restaurants. So we have 5,000 devices in restaurants, and that could be a point-of-sale device, a printer, lots of devices in the restaurants. And we also send orders out to partners. So you might order directly with your local takeaway, but the delivery might be fulfilled by a Deliveroo driver, and we manage that for the restaurant. So we take the order and send it on to Deliveroo, schedule a driver, and make sure it's delivered. So today we're going to talk about some monoliths. I wanted to first introduce the characters. So we have Zeus, and we have our RMS. The RMS is our point-of-sale system. But first, Zeus, it's our online ordering platform. So this is what powers the websites. It powers the online apps, and it's an ASP.NET web app. It was started in 2014. And it was using a very modern tech stack for 2014, and that's where it's calcified. It hasn't moved forward since. So it runs as an Azure App Service. It uses a SQL database, a Redis, table storage, pretty standard stuff. And it uses Service Bus as its queue for back-end events, async events in the back end. Very straightforward tech stack, kind of LAMP stack. In preparing for this talk, I was asking within Flipdish, how could I describe Zeus to you all? What does it do? And my colleague Adam pointed out it's easier to describe what Zeus doesn't do. So it answers telephone calls with Twilio. It's got a URL shortener, website builder. It can terminate SSL for thousands of websites. It can build QR codes for ordering at the table. My favorite feature, it can build iOS apps and submit them to the App Store for review right from within the monolith. So it's a true monolith. It does everything. So the RMS, that's our point of sale. It came in through a company we acquired in 2022. And it's got a very similar tech stack to Zeus in terms of its shape. So that was actually one of the reasons we liked this company as part of the acquisition process. They use Node.js. But apart from that, it's an Azure web app. It's using SQL, table storage, Service Bus queue. So it was a shape we were familiar with. But what differentiates this from Zeus is that it's a modern system. It's got a well-structured code base, and that's something we want to protect. So what problem are we trying to solve? This is the most important question that any engineer can ask. This is RAM. This is the RAM we had to send out to all of our developers to put into their laptops because Zeus got so big that no one could build it anymore. So we had to courier out RAM and the special screwdrivers for Lenovo laptops to open them up to put the RAM in. So the Zeus, the code, the stack, the tests, the deployment, they all slow down our delivery. We're going to drill into each of those areas. So first of all, the code. Writing code is slow. Things that should be instant and things that are instant on other platforms take us minutes. So here's screenshots of me loading Rider. Before your Rider project loads and your IntelliSense is ready, you're sitting there 2-3 minutes. So we've got this kind of relationship here. So the time to open the editor is going to increase linearly with the number of files we have. And as Zeus has got bigger and bigger over the years, the time to just open it up to make a code change just goes up and up and up. So the stack, it's on an obsolete technology stack. It's using old .NET framework. It's stuck on IIS. It's using ASP.NET, not the new ASP.NET. Entity framework, but not the new entity framework. And we spend our time fixing problems that other teams don't have. So again, this is, I think last week we had an incident where our web portal wasn't loading and I instantly knew what was up. Thread exhaustion. In a thread pool, there's a specific spot in ASP.NET where we can't run async await code. So we've got blocking code that hits the database and hits Redis. And we're stuck. There's no way that we can fix this without massive refactors. Testing. So testing Zeus is slow. We've low unit test coverage. And what do you do when you've got low unit test coverage? You start writing integration tests. The code is hard to test. It's not got much separation between database operations and web requests, so it's like molasses trying to write any new tests. And again, we've got this relationship. So the time to run the test suite increases as we add tests, and also we've got these integration tests, loads of them. So the time of any one of those being, the chance of any one of those being flaky increases with the number of integration tests. And we all know integration tests like to be flaky. So deployment. Deploying Zeus is slow. The pipeline takes an hour. That limits our time window of when we can release. We don't release at dinner time, as we call it. So we stop deploys at 4 p.m. So we've got kind of 5 deploys a day max. But realistically, what this means is if you write any code after lunch, you can't deploy it until the following morning. So you're adding 24-hour latency for any work. It's slow. These problems compound. So when you're trying to fix these problems, it's slow to release the code, which means it's slow to refactor. So you can't improve the speed to write the code because it's slow to release. They just compound and compound, and you end up with this shape. So the addition of all those linear graphs we saw, we get this exponential slowdown, where the time to ship a change just goes up and up exponentially. So what problem are we trying to solve? That was the most important question that any engineer can ask. We've got 2 systems. So like I said, we acquired a company with point of sale. So the existing Zeus system does online ordering. RMS is our point of sale, and there's a little overlap between the two. And if we zoom in on the overlap, we've got things like user accounts, audit logging, opening hours, vouchers, loyalty programs. There's a lot more than we'd anticipated in that overlap. So we have 2 systems, and that's confusing for a lot of people. Our clients, who are the restaurant owners, they have to log into 2 different portals with 2 different usernames, 2 different passwords. We've got different settings to keep in sync, so you've got to update your opening hours in one system, update your opening hours in the other. And then our customers see different online ordering experiences, depending on whether they're ordering with one system or the other. And we'll drill into that shortly. But first, I want to take a step back and talk about our ecosystems team at Flipdish. So 2021, we set up a new, fully remote team at Flipdish. At this time, Flipdish was experiencing massive growth because during the COVID pandemic, every restaurant started doing delivery, takeaway. So Flipdish scaled up massively. After COVID then, we've had 2 right-sizings of the company. We've been through some layoffs, and we've been through 2 or 3 leadership changes, kind of from the start of COVID through to today. But at every point in time when we changed, we always wanted to keep the ecosystem team together because they were the team that were delivering. They had high morale, they were collaborating well. And this really struck in my mind that we wanted to keep this team together, and I was keen to understand why. So what were they building? They were managing integrations in Zeus. So the likes of Uber Eats, Deliveroo, not sending the orders out to the partners that we talked about earlier. And they were building new integrations, crucially, outside of the monolith. So they had this kind of setup. So the online ordering system would send out webhooks. Each one would be caught by an Azure function, which had one job: to send the order to Deliveroo or to Glovo in Spain, Uber Eats, or to update maybe you edit your opening hours in our portal. We'll update that on Google Maps, these kind of updates. So they had this integration engine, and what was happening was each integration was its own Azure function. It had its own deployment pipeline, separate tests, they had no release windows, and they were able to do things we couldn't do. So they could upgrade incrementally. So over time, they went from .NET 5 on Windows to Linux, they went to .NET 6, they went to .NET 8. They were able to do all of this because each integration was a separate small piece that could be upgraded independently of the others. And interestingly, they had hit desperate problems running on Azure Functions and actually migrated to Azure's container system running on top of Kubernetes away from Azure Functions. And again, there was no downtime, it was no hassle. They were just able to spend a couple of days porting across. So today, they've got 7 integrations running, 3 shared services. They've got a lot of requests going through. Their SLIs are great. They're doing great. So I'm going to fast forward back now, 2024. Loyalty 360. So what problem are you trying to solve? This is the most important question that any engineer can ask. This problem earlier, we have 2 loyalty systems, one loyalty system for online ordering and one for the RMS. We have this problem. The way it manifested for our customers was if you had a loyalty campaign, your 5th order free, you might place 3 orders online, you get 3 stamps on your loyalty card, you then place 2 orders over the phone, and you get 2 stamps in a different loyalty card in a different loyalty system. So you've placed 5 orders, but you've got no free meal. So that's the problem we're trying to solve. This was a burn the ships moment at Flipdish. We decided we're not going to try and fix Zeus. Over the years, we've had many, many teams try to split up the monolith, carve up the monolith, upgrade it. They've all failed. And we're also not going to build new features into the RMS. We want to protect its code base, and we want to avoid it becoming the new Zeus. We also wanted to solve this problem using the same tech stack that our competitors would be using. So any new company starting in 2024 would have access to tools that we didn't have in 2016. So we wanted to make sure we were using the modern stack and also empowering our teams with autonomy and confidence as we went. So key to this project was going all in on serverless. We called the project Loyalty 360. And it was a new greenfield implementation of loyalty. So we didn't carve up the monolith. We just were able to remove the loyalty code from Zeus, remove it from RMS, and have greenfield new code for the new loyalty system. So we had a small team, 5 people on the team, 3 engineers, a product manager, a product designer, and a very short timeline. So this was crucial for us. We had a particular restaurant that was commercially sensitive for us that had this problem, so we agreed to solve it for this one client within 2 months. That was the time frame we had. We had support from the CTO driving the project, and we had an SRE and an infrastructure expert on hand to help us out. So how can we build outside the monolith? The ecosystem team had shown us the way. So our new serverless first stack, everything runs on AWS Lambda. We have an event-driven architecture using EventBridge, storage in DynamoDB, and crucially, all infrastructure as code using AWS CDK. The old world of Flipdish, a lot of ClickOps around the Azure portal, which we just don't allow now in our new AWS world. Another tool we leveraged was SST. So for those that aren't familiar, SST is a framework that sort of complements and slightly sits above AWS Lambda. It gave us a lot of benefits over and above using just AWS Lambda directly. It has sort of opinions on how you structure your code. It has a great deployment story that packages up deployments for us nicely. And it also doesn't abstract away the CDK. So when you're using SST, they provide CDK level 3 constructs that you can use. But if there's something that you want to do outside of SST's kind of core, you can bring in your own CDK CDK constructs, so you're not isolated for anything. SST lets you have direct access to the layer below, which was key for us, because we didn't want to get boxed into using some tooling, which might run out of favor and stop getting updates. So in this project to build loyalty outside of Zeus, we hit 2 roadblocks. The first was that the authorization system was stuck inside Zeus. The second problem was that we had no access to the domain events inside Zeus and inside the RMS. So when an order is created in Zeus, we want to stamp a loyalty card. When a sale is completed in the RMS, we want to stamp your loyalty card. And they were on those Azure service bus queues, like I mentioned earlier, stuck inside each of the systems. So for the authorization, we went into Zeus and we added a new HTTP endpoint, which would let us post whatever credentials we had to Zeus, and Zeus would return us back a little JSON document saying who the user was, what permission grants they had, what access they had. Zeus being like an 11-year-old code base at this stage, there's a lot of different types of authentication it allows, so writing this code was a bit tricky, but we were able to wrap it up nicely in an AWS Lambda authorizer, which isolates our teams from having to see the gunk we needed to do to expose the authorization outside of Zeus. And then for getting the events out, we came up with an amazing solution. So the idea was from the service bus, we could trigger an Azure function, which could then make a HTTP call across clouds into a Lambda, and that Lambda could take the event and put it into Event Bridge, and we could listen to that. And we quickly said no. So we needed to focus, and we just wrote a very short 10-line C# function just to take the same event that we were putting to Event Bridge, and also, the same event we're putting on Service Bus, and put it on Event Bridge. It's 10 lines of code, and it works because we need to focus on what problem we're trying to solve. We're not trying to fix Zeus's event system. We're not trying to build a new authorization framework. We're trying to solve loyalty for this one client to solve that loyalty card problem. So this is the highest level architecture that we came up with. You can see on the left-hand side, we've got the Azure world with online ordering and point of sale. They publish events to the Event Bridge, and then our Lambda runs in AWS. It's totally unaware of the existence of Azure or the services therein, and it can do its loyalty thing. So the results. I'm going to go through the points we had earlier in Zeus. So code, as we said. Writing code is slow in Zeus. SST gives us hot reloading of Lambdas. So as you're typing away and saving in your editor, the Lambdas update immediately. And the key thing here was this wasn't a speed increase of we didn't get a 10% speed up or a 50% speed up. It went from taking minutes to make a change to being instant, which is just a sea change. SST also gives us hot reloading of infrastructure. So if you open up your CDK file and you maybe give yourself a new DynamoDB table or a new S3 bucket, you just save your infrastructure file, and SST immediately just deploys whatever it is you need. You can think back to the previous world. That would have been creating a Jira ticket for someone to go into Azure and click some buttons, and you'd be waiting weeks for your new infrastructure. Testing. So it's a greenfield project. We can start writing the project tests first. The tests run in watch mode, so they run instantly as you're writing the code. You save the code, the tests run. And SST lets us write tests for our infrastructure, so we can write unit tests against the CDK, as well as writing tests against the code, which is something we were never able to do in the past. These benefits compound. So with Zeus, we had all these problems compounding, slowing us down, but the opposite's true here. All the benefits we get compound into each other positively. So this was the graph we had of the slowdown as we added more and more features to Zeus. This is the situation we're in now. We can't escape that exponential growth. If any service gets big, it's going to slow down in that way. But by splitting the services up, we artificially limit the size of the services, and we artificially constrain that exponential growth. So what's worked well for us? Having one repo for everything. So the service is in a repo on GitHub. We've got access controls already set up for GitHub, so we can manage employee onboarding and offboarding. Our deploy pipelines are in GitHub Actions, again, in the repo. Our secrets can all be managed with GitHub Secrets. So this has worked really well for us. We can give each team full admin access to their GitHub repo, and they can manage it as they want. If they want to be shared source, if they want to allow other teams pull requests or not, it's all up to them. AWS accounts, we use them like a bulkhead between teams. So each team has 3 AWS accounts, one for ephemeral, one for prod staging, and one for production. And that isolates what teams can do. So me on one team, I can't make any changes that can affect another team's AWS accounts. It isolates observability and, crucially, costs. We can just go into Datadog and look at the costs per team stack and immediately see the costs. Before, with everything in one big Azure account, we just have the number of dollars we're paying, and you've got to do forensics to figure out where the money's going. So what hasn't worked well? Serverless has been great for us, but we've hit a bunch of problems. Data migrations. When we're writing new systems outside of Zeus, we have that gravity of the data still existing inside Zeus, and we haven't come up with a pattern we've been really happy with for getting data out of Zeus. We've had a bunch of successes in different patterns, but as we spin up more and more projects, we find the migration needs to be different each time, and it's been a big slowdown for us as we migrate. This hasn't been a problem for new features. When we build a new feature on the new stack, it's a clean slate. We've got no migration, but as we're pulling systems like loyalty out of Zeus, we need to make sure your loyalty stamps are transferred across to the new world. So we've hit some difficulties there. Love to talk later about data migrations if anyone wants to have a beer. Uncertainty. So we've asked an awful lot of our teams. So a lot of our developers were C# developers, used to Azure, used to SQL databases. We've asked that they learn Dynamo, they moved to TypeScript, moved from Azure to AWS, and we've had a lot of we've asked a lot of them, and it's taken some time for us all to get up to speed. So we're there now, but we're happy that everyone on the team came along with us because we asked a lot of them. So this chart here shows the timeline where we shipped. So at the start on the left, you can see where we turned on Loyalty 360 for our new clients. So this solved the problem that we had. Solved the problem for that one restaurant, and shortly after for all new restaurants. But then crucially, the point on the right is where we turned it over. So once we'd done that full migration for everyone, we were able to switch across. So our customers and our clients, so the people ordering food in the restaurants, got all the benefit there on the left-hand side. We'd solved the problem. But our engineering team only got that benefit there at the right-hand side. Once we finished the migration, that's when we got to delete the code from Zeus and the RMS. So the payoff came in 2 stages, and that was key learning for us there, was that the benefit doesn't come until the project is fully complete. So 2025, what's happened since? Micro front ends. So what problem are you trying to solve? This is the most important question that any engineer can ask. A third monolith appeared. So our UI, this is the web portal that our clients, the restaurants, log into to manage their opening hours, manage their menus, etc. It's a single-page React app bundled with Vite, and it hits all these same problems we have in Zeus. Teams block each other. We've got flaky tests. It's a single code base. All those same problems. Slow to upgrade. React Query and MUI, I'll call those out explicitly for breaking changes constantly that we need to upgrade. So this is what a typical page looks like in our portal. And this is how we've broken it up. So we allow teams at the top, they can specify a path that they want to carve out. They can add a menu item there on the left. And then that pane that I've got with the dashed outline there, that's the micro front end itself. And that piece is in the same repo as the service. So that, what we've been able to carry through from the previous project was having one repo with now the back end and the front end and the infrastructure as code. We've got the same live reloading experience. So now, when a developer is building a new feature within the new world, they can start the back end. They can start the micro front end and develop on just those two, and they never need to run Zeus, they don't need to run RMS, they're totally isolated, and they're in this world with the instant feedback, so make changes to the front end and save it. The UI updates instantly with Beat, make changes on the back end, SST gives us the live reloading. The front ends then can all be tested independently, and the teams can all deploy independently. So where are we today? All new features are being built on the new stack, which we're delighted with. All teams in Flipdish are now building in this new world. And crucially, are we shipping value? So this was the first feature that a team built outside of Zeus that was a whole new feature. So you can see this was a marketing service to let us send SMS to clients. You know, maybe you haven't ordered in a month. Would you like a 10% off voucher if you order? The blue ramp-up period here is where we did our internal testing, and then we did a marketing email out and got that bump there in red. So all this to show that we're building outside the monolith, and we're building features that are valuable for our clients. Our number of deploys as well. This is rough data taken from Datadog, but over the last couple of years, deploys are up 10x from where we were before with Zeus, all powered by this new stack with the speed of delivery really being prioritized. So that brings us to the end. Thank you, everybody. And final note, we're hiring in Dublin if anyone is interested in a career at Flipdish.
Awesome. Please do stay there, Marc. Are there any questions? Normally takes a minute for people to put their hands up. 20 seconds. Anyone? Always at the back. Say that again. No. I'll come to you. Or will I? Excuse me.
Just wondering how you implemented the micro front ends. Was that an iframe or some fancy live loading of the micro front end within the sort of framework?
Sorry, could you ask that one more time, please?
How did you implement the micro front end? So how did you get the micro front end within the framework of the rest of the site?
That is a topic that I'm not too familiar with. So they are an iframe within the site. The code, it gets bundled up into an S3 package, and then I know the iframe, I think it's a script tag that points to where the bundle is, but I'm not familiar with that piece of code. But I can put you in touch with the man that is if you've any questions.
Cool, thank you.
Super. Yeah, go on. We'll do one more question. If anybody is going to a different talk and not staying in here, do feel free to move to the next session. In here next, we have Ryan Cormack. Where were you? Ah, great.
I was just curious why you moved to TypeScript, because I think you can write .NET in Lambdas, I think.
Yes. We moved TypeScript to try to align all teams on a single language. So we have web ordering, and our website builder was in TypeScript. Our portal was in TypeScript. But then we also have a bunch of React Native apps, so we've got kiosks and stuff. So it's funny, when you're looking at it from the point of view of one of our back-end developers, we're asking a big change of them. You used to work in C#, we're going to move you to TypeScript. But when you look at sort of the staff level view across all the engineering teams, TypeScript was used for more projects than C# was across the board. So big change for our back-end developers, but engineering-wise within Flipdish, it was moving sort of 80%, from 80% of projects in TypeScript to 100% in TypeScript.
Well, at least it's strongly typed, so you know, it's all right.
Yes, indeed, yeah.
Thank you.
Great. And if there are more questions, are you around for a little while, Marc?
Absolutely, yeah.
Wonderful. So another round of applause, please, for Marc. Thank you very much.